Hi everyone. In this video I am going to construct 4 to 16 decoder using two 3 to 8 decoders. As I said in the last video, 3 to 8 decoders are the basic building blocks of 4 to 16 decoders or higher order of that. So we have seen 3 to 8 decoders where 3 inputs are there like A, B, C and 8 outputs are there like D0 to D7. The corresponding output line D0 to D7 is activated based upon the input combinations. Okay. So along with the inputs D0 A, B, C, we are also having one enable pin. Okay. Suppose if you take a 3 to 8 decoder, for example, consider a 3 to 8 decoder, 3 to 8 decoder, 3 to 8 decoder also represented as 3 by 8, like this 3 into 8 decoder with active high enable pin. Active high enable pin. Why I said active high enable pin is there are two types of versions we have in the active combinations, like active high enable pin and active low enable pin. That means active high enable pin means active high enable pin says that when enable is equal to 1, that corresponding IC or chip is activated. When it is 1, the chip is activated. Active low enable pin means if that enable pin is equal to 0, that chip is activated. In remaining times it is deactivated. That means when E is equal to 1, if it is the active low enable pin, E is equal to 1, that is chip is deactivated. That is the meaning of active low or active high enable pins. Okay, generally we consider active high enable pin, but when we go into the IC implementations, generally most of the ICs which are fabricated with active low enable pins. Active low pins are commonly preferred because it takes low levels. It takes low level and it needs low power also to operate them. Okay, that is the reason behind that. Okay, so active high enable pin we are taking for our understandings. Now I'm taking a 3 to 8 decoder which has 3 inputs and one enable pin. 3 inputs and one enable pin. So A2, A1, A0, these are the 3 inputs, and we have outputs like D0, D1, D2, D3, D4, D5, D6 and D7. Total 8 outputs. D2, D3, D4, D5, D6 and D7. Okay, this is what 3 to 8 decoder. 3 to 8 decoder with active high enable pin. With active high enable pin. Here the entire operation of this 4 to 16 decoder with, using 3 to 8 decoders is completely depending on this enable pin. Enable pin plays very key role, important role in the designing part of higher order decoders with lower order decoders. Okay. Now, the truth table of this one is before going to the implementation of the 4 to 16 decoder using 3 to 8 decoder. So, let us consider the truth table. We know very well the truth table has 4 inputs and 16 outputs. So, output we are taking it as a single column output. Okay, output means it may be D0, D1, D2, D3 and so on, D15. The corresponding pin is activated. Okay, so take 0 0 0 0 4 zeros 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 and triple 1. All these are zeros. Okay, and when 4 zeros are there, output is D0 and similarly D1, D2, D3. What is the meaning of this D0, D1, D2, D3 is when 4 zeros are there, you can take also in the other way like D0, D1, D2, D3 up to 16, up to total D15. So 0 to D15, D0 to D15, total 16 pins you can take horizontally, and the corresponding output bit is activated by giving 1 and remaining all are zeros. That is one way of representing, but it takes a longer space. If you are taking output as a single column and the corresponding bit which is activated, I am just mentioning that it means the remaining all are zeros. The remaining all are zeros. Okay, so D0, D1, D2, D3, and it is D4, it is D5, and it is D6. Something we forgot, it is D6, and 0, 111, this is D7. Next one, 1, 000. Again same 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and again 4 ones. Okay, so here it is D8, D9, D10, D11, D12, D13, D14, and D15. Okay, see here we are having total 16 outputs with the combinations of 4 zeros to 4 ones. If you observe clearly, A3 pin is 0 for first 8 combinations. Observe clearly, students. A3 pin is 0. See here, A3 pin is 0 for first 8 outputs, and again A3 pin is, this is A3 pin. A3 pin is 1 for the remaining 8 outputs. Okay, that means if the first 8 outputs are implemented with one 328 decoder, by making the enable pin as by making the enable pin as 0, we can use the first 8 outputs from the one decoder, and by making enable pin as 1, and the remaining all are one more 328 decoder. Okay, so what is the meaning? What I am saying is, we are taking two 328 decoders, one 328 decoder is activated when enable pin is equal to 0, and one more 328 decoder has to be activated when enable is equal to 1. Like that we are going to give. Okay, I will construct here. So 4 to 16 line decoder using two 3 to 8 decoders. Two 3 to 8 decoders. So as I said in the first slide, this is a 3 to 8 decoder, and one more 3 to 8 decoder I am taking. So 4 to 16 decoder with 3 to 8 decoders, because the total number of outputs will be tallied. So it is 8 outputs it is having, and one more 8 outputs are coming from this one. The entire logic is depending on how the inputs are going to be set. Okay, so we have outputs D0, D1, D2, D3, D4, D5, D6, D7, and similarly D0, D1, D2, D3, D4, D5, D6, D7. So if you take D0, D1, D2, D3, D4, D5, D6, D7, it will be continue like D8, D9, D10, D11, D12, D13, D14, and D15. So for first 8 outputs are coming from the first decoder, and the remaining 8 outputs are coming from the second decoder. So 3 inputs are there, A0, A1, A2, and again here also we have three more inputs, A0, A1, A2, all these are common inputs. Along with that, as I said, we are also having one enable pin, So this enable pin is nothing but your A3. This enable pin is nothing but your A3. See, for the first decoder enable pin is 0, second decoder enable pin is equal to 1. So first decoder we are taking, it is NOT gate. I will draw it again. Okay, and here this is the second enable pin. So you can also join all these. So this is the first input, second input, third input. A0, A1, and it is A2. Okay, so A0, A1, A2. Now see, for example, 000 and 0. Four zeros are there. Four zeros means which is the output D0. So as it is 0, this 0 A3 goes inside and that makes the second decoder deactivated, because 0 is applied to the second decoder and 0 will be inverted and applied to the first inverter. So 1 enable pin is equal to 1 in the first decoder. That's why first decoder is activated and it is working. So for all first 8 outputs, for all first 8 inputs, 0, 000 to 0, 111, for all first 8 inputs, first decoder will be activated and the remaining 8 inputs are nothing but, then A3 becomes 1 and again the process started 000 to 111. So at that time first decoder is in deactivate mode and second decoder is in activated mode. Okay, so like that we can design 4 to 16 line decoder using 3 to 8 decoders. The designing is very important. Outputs, of course, number of outputs may be equated, but the designing of inputs is difficult. Setting the inputs, see three inputs are here, three we can manage, but the fourth input, how we are giving the fourth input, must be acted like a enable pin. Okay, thank you.